Hello everyone, this is Hippo. Today we will talk about 3A2. It's about ionic compounds radii. So for the cation, it is a small radii of their parent atom because it loses the shells and size. Like the sodium and sodium ion, sodium has three quantum shells, but the sodium ion just two. So more shells, but if they are not decreasing the quantum shell, we can see that there's repulsion between the electron and electrons. It's also a factor of that the ionization energy. So for the anion, the negative ion, it is just a reverse. Okay, to the diagram. This diagram is wrong because we don't need to draw the best fit line for this tendency. We have to separate the cation and the anion into two tendencies. So two lines like this one. And also, these have the same number of electrons. They are called the isoelectronic species. They have the same number of electrons, but it's different number of protons. So for the radii, the larger number of proton, larger nuclear charge, therefore the smaller radius because the big attraction between the nuclei and the outer shell electrons. So there are four different compounds we have to say in unit 1. The polarization energy I will talk about in 4 or 3 units after this class. So the first two is called the pure ionic compound, and the second is pure covalent compound, and the third is ionic compound with some covalent character, and fourth is a covalent compound with some ionic character. So for this one, 3, 2, the ionic compound don't have overlap like this. Is positive and negative ion, or this. The cation distorts the electron density of the negative ion. This is called the polarizing power. More polarization power, it can distort more. But if there are overlap, it will cause the molecule. No overlap. Okay, we have to notice that the key definition, the polarization energy. Okay, for the factors that affect the polarization energy, is the distorted or polarizable. For the cation, it has small size and higher charge because the small size that the nuclei can attract more, can have less repulsion of the inner shells. So they can avoid some shielding effect, avoid the expensive positive charge, and for the anion, they have to have the higher charge or the larger size, because the bigger the electron cloud will be easily experienced or attracted. So anion polarized since even distribution of the electron density have been distorted. For example, which has the greatest covalent character? Alright, it's magnesium bromide. Why? First, they'll need the higher charge. So sodium have only one charge, but magnesium have two positive charges, so these two are passed. But for the bromine and fluorine, for the anion, they have to have larger size, so bromo has larger size than fluorine, so it is this.